During a very quick stop, a car decelerates at 7.00 meters per second squared. Right. When the car decelerates, the tires will decelerate at the same time. And the acceleration of the car or deceleration of the car will be equal to tangential acceleration of the tires. So what are we given here? We are given the tangential acceleration of the tire because that's equal to the acceleration of the car. Therefore, the acceleration is in opposite direction, so negative 7 meters per second squared. So what is A asking for? Given the radius of the tire, which is 0.280 meters, we are asked to find the angular acceleration. And we know that angular acceleration is related to tangential acceleration in the radius as follows. Tangential acceleration divided by r. Because the tangential acceleration is equal to r times alpha. Alpha, or the angular acceleration, is tangential acceleration divided by the radius. Alright, so we are given the tangential acceleration as meters per second squared. Divide that by the radius, which is given to be 0.280 meters. And that yields negative 25.0 radian per second squared. B. How many revolutions do the tires make before coming to rest? Given their initial angular velocity is 95.0 radian per second. Coming to stop means omega f is equal to 0. And we are given omega naught, which is 95.0 radian per second. And what we are asked to find is delta theta in revolution. So given the two angular velocities and the acceleration or rotational acceleration, can we get delta theta? So we have omega f squared minus omega naught squared over 2 alpha is equal to delta theta. Plug in the numbers. And that is from omega f squared equals omega naught squared plus 2 alpha delta theta. Just rearrange. Plug in the numbers. 0 minus omega naught is given to be 95.0 radian per second. Square it. Divide that twice alpha, which is calculated in A to be negative 25.0 radian per second squared from the tangential acceleration is radius. That yields 180.5 radian. But we are asked to find it in revolution. Therefore, we have to convert it to revolution. Convert it to revolution, we multiply by 1 revolution and divide by 1 revolution equivalent radians, which is 2 pi radians. That's equal to 28.7 revolution. C. How long does the car take to stop completely? Delta t is required, time, elapsed of time. And you know alpha is equal to delta omega divided by time, therefore time will be equal to delta omega over alpha. That is omega f minus omega naught divided by alpha. Plug in the numbers. 0 minus 95.0 radian per second divided by alpha, which is calculated in A to be minus 25.0 radian per second. Squared. Radian per second goes away, 1 second is second, so the unit is second. Negative divided by negative is positive, and the number is 3.8 seconds. What distance does the car travel in this time? So delta x is required. And we know that delta x is equal to r times delta theta. Alright, delta theta that we use here is going to be in radians, this value here. So r is 0.280 meters. Multiply that by delta theta in radians, which is 180.5 radian. That's equal to 50.5 meters. E. What was the car's initial velocity? V naught is required. And we know that V naught is equal to R omega naught. Plug in the numbers. 0.280 meters multiplied by omega naught, which is given to be 95.0 radian per second. That's equal to 26.6 meters per second.